in the thread, they will be those changes will be immediately reflected in main.
Yes. Because if you look at section 7 and look under P threads, it explains what type of resources are shared amongst all the threads and which part are common. So POSIX.1 requires that threads share a range of other attributes. Okay, the first part, okay, let's redefine manual from the start. Specifies a set of interfaces, functions, header files, basically the API or application programming interface. For thread programming, commonly known as POSIX threads or P threads, a single process can contain multiple threads, all of which are executing the same program. These threads share the same global memory area, data, and heap segments, but each thread has its own stack or automatic variables. But they can see each other's stack as well. So that's the thing. I mean, they can actually see each other's stack, and as such, they can also corrupt each other's stack. POSIX.1 also requires that threads share a range of other attributes, i.e. these attributes are process-wide other than per thread. Process ID, parent process ID, I mean, these are all fairly common, common sense because they are really of the same process. Controlling terminal is also shared because the controlling terminal is shared because the open file descriptors are shared. And signal dispositions are shared. In other words, if one thread says, I want to ignore this particular signal, then it will be ignored in all the other threads because the signal disposition is also a process level type of concept. The signal mask is not. Okay, that is important because the signal mask basically enables one thread to say, I'm not listening to any signals. Don't bother me. Whereas you can leave one single thread in the entire process to listen to the signals, and that thread becomes basically the signal processing or signal handling thread of all the threads in the same process. Current directory, interval timers, nice value, resource limits, and so on and so forth. So these are all shared. What is not shared, if you read this part here, as well as the stack, POSIX.1 specifies that various other attributes are distinct for each thread. The thread ID is not shared. That's kind of intuitive because ID is the identifier. Signal mask is not shared. Burnham Variable. So this is really kind of a misnomer because it really is not a variable. It's the dereferencing of a pointer returned by a function. So technically speaking, it is not a variable, but it is used as if it is a variable. Alternate stack, signal stack, real-time scheduling policy, and priority, which makes sense because of the same process, some threads may require real-time scheduling, and others may be sitting in the background doing some sort of slow I/O. So amongst all the threads of the same process, you can actually change the priority of each one accordingly. And this is also interesting because you can actually set the CPU affinity of a particular thread. In other words, you can basically say this thread wants to be, if possible, I want to run on that processor. So we can just look that up. May or may not have the man page loaded here. Oh, there you go. So you can set and get a process CPU affinity mask. A process CPU affinity mask determines the set of CPU on which it is eligible to run. On a multiprocessor system, setting the CPU affinity mask can be used to obtain performance benefits. For example, blah, 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 blah. It is represented by the structure like that. So this is no longer just applicable to the entire process because each thread also has its own mask. Any questions at this point? Yep.
I was just going to mention that I believe this was used when they did the proof of concept for the security flaws in hyper-threading, showing that you could in fact pull information out of the L2 cache that was intended for the other thread, thus figuring out that encryption keys or passwords or other stuff that would be available in plain text on the CPU.
Nice. That makes sense. Oh, did you guys know that someone found a security flaw of all virus scanning software.
Oh yeah, I was reading about that too.
Yeah, it's like a universal approach that will basically break any virus scanner known at this point.
It requires some tricky timing to make it work. I mean,
Right.
you have to know exactly what version you're attacking, and it will only work for that version of a particular piece of antivirus software
Right.
under a given system load.
Mm-hmm. And it's based on a bait and switch technique. And I don't remember the exact details, but if you look for antivirus bait switch, I'm pretty sure you'll find the original article that describes the approach. The reality is, it is unlikely to be found in the wild because, it has the code for this type of payload is going to be pretty big, which is not, stealthy at all.
Download Windows.exe at 500 megabytes.
Well, I was going to say Windows 7, I mean, it's like 8 gig install. I mean, there's plenty of room to hide stuff there.
Yeah, but the file
Just
size will
append
change. The
random
file
to the
size,
end.
of the infected file will change significantly. That's the
Assuming
problem.
they aren't using the second stream on Windows NT and running it with, what do you call it? They've got the alternate
You
data
can
streams.
hook it anyway though and hide the size of the file. Just hook the system call and hide the file.
But doesn't that
Anybody
mean
can
you
see
have
it.
to have a rootkit installed already?
Windows has got plenty of files already. The rootkits are, I mean,